Welcome to Let's Make a Game Platformer, episode 40. In last episode, I've done some refactoring to speed up the startup of the game. And for this episode, I've created this level, which, as you can see, doesn't allow me really to pass here. There's an obstacle I cannot jump over or anything like that to get to the exit. However, there is this curious blocks here, and seems to be a ramp behind it. So if you were following this series from the very beginning, you might be wondering how did I use the 3D rendering for a platformer, which is clearly a 2D. At the moment I can move only left, right, and jump. That's because this is what I was planning. Actually, I was planning to make the platformer not a 2D, but 2.5D. So not fully 3D. There is the movement in the third direction is going to be limited. One way of doing this is just by using some block or specific mechanics in the games to allow you to move in the Z direction. So this block that I've added here, and I've defined it here. Here is one of these mechanics that will allow me to move between the layers in the Z direction. So the plan is that whenever a user gets over the block, uses the activate key, so E or right shift, the same key that was used for levers. The block will actually move the player to the layer that it's pointing at. So this way to the back, to the front, away from the player, away from the camera, and this move it back towards the camera, this block over there in the back. This way I'll be able to walk around this obstacle here. Okay, so to achieve this, I'll have to do a couple of things. So let me make a quick list. First of all, I'll have to create a system that will move an entity that has activated an entity. So player has activated this block entity. And the entity, this block, will have a specific component, and the component will contain the information what's the distance that the entity that activated it should be moved. So in this case, it's going to be away from us or towards us. Second thing I need to do is create a system that will play an animation on an entity that has activated an entity with a specific component. This is to show the walk animation whenever this block moves the player away or towards the camera. So there are two first things. And that would achieve what we wanted. However, that's not the end. So I have to do a couple of other things. First of all, when the player transitions from moves between layers in Z direction, I have to make sure that the player doesn't move with arrow keys on jumps or does anything weird, because stuff will not work for us. So what I need to do is to create an event that physics system will use to check if a specific kinetic entity should be processed. This is the same event we can use in the system that is responsible for maintaining state of the level. So when the level was finished, and for example, when the level was finished or player died, we might actually stop processing physics events for that entity. That's something that we can use as well. Fourth thing I need to do is, because we'll be having now multiple layers. Like you can imagine, in the first layer, it's going to be the layer with the blocks the column of blocks that I cannot go through. However, I should be able to walk around this column. At the moment, our collision detection works without knowing anything about the Z layer. So this is something that I have to do. So I have to modify the get collision point event to send a Z layer, so like a Z coordinate of the entity is on, and I'll have to change the physics system to pass that information in that event. Next thing, so once we got through this, we have to modify all systems that receive the get collision point event to process the collisions, to check for the Z layer when considering the collisions. So for example, in our platform case, we have to only look at those blocks that are on the same Z layer as the moving entity, and so on. And finally, the last thing is there's one more place where we are checking whether things are on top of each other or very, very close to each other. This is the hitbox overlap system. So we have to modify the hitbox overlap system to consider the Z layer when checking for overlaps. For example, if you have a pressure plate in one layer and you're moving on a different layer, even if the X and Y coordinates are the same, you should not be activating that pressure plate because, well, you're not where the pressure plate is. So by doing this 6 easy steps, actually only 5 of them are required because the animation is like optional. I just want to have a sort of a thing there. If we finish this all steps, we basically changed our 2D game, 2D platformer, into a 2.5, or depending how you look at it, 3D platformer. And the changes seem to be very small, and that's the beauty and strength of the entity systems with components. Okay, so let's get to it. First of all, we'll have to create a system that will move entity. Okay, so in gameplay logic, does it belong anywhere? Transform. Yeah, transforms look good. So let's package whatever we had there before. This is the system that translates something. We actually, oh, by the way, we're going to be using this for moving the player. So activate package here. So system that will move an entity, move activator system. So we'll have this class in profiles gameplay, and I will have an component, move activator component interface, extends component, and as I said, it will have to contain information what's the distance to move the activator by. So float get distance x, y, and z. Okay, so let's maybe add this here. Move activator component, and distance z, we have to move it by away from the camera, so -1. And this is the block for moving it back, so towards the camera. And in here we'll do distance z1. Okay, so that was the easy part. Now let's write the code. So first of all, we have to receive the event. And so move activator. So it was activate entity. So when something activates entity, and the entity has to have the move activator component, we'll have to check what was an entity that has activated it. At the moment, we don't have this information in this event, so let's modify it. We'll fix it quickly. So it will say activator, create a constructor and the getter, and find where it is used at the moment here, and what activated is the player here. So this is the entity that has activated this entity, this block in this case. And so here we'll do get activator, and on that activator, as we can see, as I said, we have to use the translate over time. We have to add this component, create component, model translate over time. Okay, so we have to call a couple of setters here. So first setter is set source x. Okay, so First of all, we need timer, the time manager, get time. Set source X is gonna be activator get component location. Activator location X, set destination X, it's going to be location get X plus move activator get distance X. And we have to do the same for Y and Z. Y let's see. Okay, so these are the things we have to set. Next, we have to set the how long it's gonna move. Start. Let's go with start time first. So this is very simple. And what else? Move time and interpolation by default is going to be linear, and it's fine. So you have to also specify the move time. So let me maybe add this to the activator component. Long get move time. Move activator get move time. Okay, and we have to save changes to the activator. All right, so we got first thing done. Is that all? Well, I have to now modify the stone front. It has already this. Let's do the move time. Let's say it's going to take a second. And do the same with the stone back. So now let me give it a try. Okay, I'm activating it. Oh, something has happened. It seems it already has model translate over time component. So the player. Okay, let me debug this quick. Okay, I found the problem. So in the model translate system that I've written a couple of episodes ago, I was checking that the component has to have a base location component, but it's not true because the translate over time has the source location, so we don't have it, don't need it there. So when I fix this, I don't have to, as you can see, it's not even used here, even though it's being extracted, we don't need it. So now if I run it, player gets moved, however, some weird way first. Okay, so let me take a look at this. Okay, so these are incorrect. Okay, x, 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 y, 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 z, 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 z. Okay, now it should be fine. Let me run it again, just to confirm. Okay, and activate, and yes, we have moved. However, as you can see, I cannot move to the right because the physics system thinks that this is something that's blocking my way. Okay, so we got the first part out of the way. There is a system that basically moves entity when it activates an entity with this component. Okay, so now maybe I'll leave the animation part to the end and work that, add an event to the physics system that will check if the processing should be done on the specific entity. So let's do a should process physics. That's a good name for an event. So physics system in here will, so cancelled is something that will say here. It will have a method to cancel it. And a getter is cancelled. Okay, and here you'll have should process physics and send it on the kinetic entity. And if it was not cancelled, we'll actually do the processing. Yeah, okay. Apply forces. We can probably also avoid doing it here. Should process physics. Send it on the entity. If not cancelled, we'll do the stuff. Okay, so that's it. However, in this activator, I have to add temporarily this something that. So let me add a new component here. Entity moved activator moved component extends component. So I'll add it here to the entity. Activator create component activator moved. I don't need to set anything, so it's going to be created. We need to save changes, and now I'll do that. Another thing I have to do is I want to make sure that we remove this as well, and I'll do this using the delay manager. So I'll schedule the removal of it. So delay manager, add delayed action on the activator with a name move activator system remove component, and delay is gonna be the time it's supposed to move, so I have to do it. I have to extract it. Okay, and here we'll have two things. Remove component, so delayed action triggered. Activator moved component. So we'll do entity ref, remove component, activator moved component, entity ref, save changes. Okay, so we are moving it, and now we have to prevent the physics to be processed. Prevent physics processing. So should process physics. So if it has activator moved component, we will say cancel processing. Okay, let me try this. I'm moving. Yeah. So I was not able to move while I was being transferred to the other Z layer. Okay, so we got another task out of the list. So next thing you have to, well, at the moment, as you've seen, I was not able to pass through the column because the collision was detecting that I was not able to. So as I said, we have to go modify the collision point event and add here int specifying Z layer and add it to the constructor here, set it, and add a getter. Okay, so Z layer. Let's find usages of this class. So first one we have in collision point where we have to specify it. So colliding object, location X, location Y. Let's add int Z layer here and we'll pass it to the collision point. Same here. In here as well, int Z layer. Okay, and now in here I have to get the Z layer. Okay, so how do we get the Z layer? So the Z layer, at the moment the player location is 0.5 and the layer is 0. So what we're gonna do to get the Z layer, we're gonna do Z layer equal to math floor of the location. No, it's not location. It's yeah, it is location, but it's in here. Of location get Z. However, I believe this is an incorrect. Yeah, we have to cast it to int, unfortunately. Unless the math from math utils is called, then libgdx has a better floor. Yes, it does. It has a floor that actually gets a float and returns an int. So we don't have to cast it. Okay. Great. So now we have to pass it here. And I have to go through all the colliders. So first of all, for the platform. So get collision point direction. No, wait. Collision point here. So I'll have to go through all the platform blocks, block obstacle. So let's add here to the, this basically defines the rectangles for all the blocks in the scene. Let's specify the Z layer for them as well. So into Z layer, this Z layer equals Z layer. And if event get Z layer equals to platform block Z layer. So if it's on the same Z layer, the block and the entity that we get collision point, and they overlap, that's when we're gonna be do the whole collision thing. And in here, when I create an obstacle, I have to do int Z layer math utils floor of float parse float location split 2 is where the Z is. X on 0, Y on 1, and Z on 2. And in here I have to pass Z layer. Okay, one more thing somewhere here. I'm missing a comma. Okay, so that fixes the collisions for the platforms. And now for all the other models. It's going to be doing basically the same thing. So we do intersects here. We also have to do the event get z layer equal to the event get object bounds rectangle obstacle translate location. This is the location of the obstacle. So we'll have here int z layer math utils floor location get z layer and okay, so that should be it. Let me check if I can now go through the column. And what I mean it by this behind the column. So first of all, check that I can't go to the column here. Let me activate it. And now I can get through it. And I can get back and I can exit. Awesome. So we got that point. Now we have to modify that, make sure that the same check, similar check, do it in the hitbox overlap system. So when we're doing an overlaps, I have to make sure that we are checking only those. So first of all, hitbox entity int z layer math utils floor of hitbox entity. So entity, so this is the entity that we are looking for. Entity get component location component class get z. This is very complicated. So we have the z layer of this entity, and now we have to check. Actually, I can do it here once we check that we are actually doing overlays. And now we have the rectangle tree of the other entity, and in here I have other entity, other shape, other z layer, we'll have other math utils floor, other entity get component location get c, if shape intersects and z layer equals other z layer. Okay, I have to do the same thing here. So find overlap entities has to also pass the z layer you are interested in getting. Okay, and here we'll have the z layer, and this is the entity we're testing. Int entity z layer math utils floor entity get component location component get z, and z layer equals entity z layer, and they have to intersect, and if they do, we do stuff. Okay, so that's it. We have to now find all the places that use the find overlap entities, and we can do it by actually building it. Okay, so in here we have to figure out the z layer of the entity. So let's do int z layer math utils floor location get c. Let me copy this code because it's going to be probably the same everywhere. Int z layer z layer, and yeah, this looks very similar. Z layer int z layer comma. Okay, so that's working. Let me check that nothing has been broken, so I can get through all the levels that we have defined. So move behind, sneakily, move back. Oh, okay, I'll have to fix this. Okay, so nothing is broken. So the last thing I want to do is to show you once more the level. It's aesthetical only. So I want to. So now when I move here, it just moves me. Or maybe actually I will leave it this way, because I would have to rotate the player, plate animation. So maybe I can do it some other time. Okay, that's it for this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter. Link is in the description. And I have one more announcement. So this was episode 40. And in the next episode, what I will do is start working on a level editor inside of the game, so that your players are. So first of all, you can see how I can approach an editor for this kind of platformer with this kind of setup. And so that you can copy paste the code, or just take the whole code as is at the moment, add your stuff and ship it with an editor, so that your players in your game can easily, or it's not gonna be completely easy because we want to do some cool stuff. So, but they will be able to actually create new levels, share them with other people, have fun. And other announcement is that starting from this week, as you are watching it, on every Saturday there will be refactoring Saturday, where I will not add any features. Just instead I will improve the quality of the code, fix some stuff I've noticed that probably it's better to have them fixed. However, I didn't want to do it really without you looking, so I want to record it, so this is going to be sort of more official. So there's going to be refactoring Saturday, where I'll just go through the code, fix the stuff I do not like, fix the stuff I'd like to unify multiple things using the same code. And okay, that's it. That's for the announcements. Thanks for watching, and bye.